Hello everybody. Topic for today's discussion is De Morgan's law. In some of the previous videos we have seen concept of sets, the union of sets, intersection of sets, complement of sets. So in this one it will be an application of all those concepts in the form of De Morgan's law. So let's just quickly go through the De Morgan's law, and then in this session I'll be covering the first one, which is A union B complement is equal to A complement intersection B complement. And what we will do is we'll take an approach of the Venn diagram and also a theoretical proof for this particular law. So let's go through the Venn diagram approach. So if you see this, this rectangle, it represents a universal set, and this green area, it represents the A union B. And if you think of it, A union B complement will be everything except this green area, which is marked by blue color in this particular image. So if you notice this, right, so this is nothing but our left hand side of this equation, which is A union B complement. Now let's approach the right hand side of things also. So in this one, what I have done is again it is represented by universal sets, which are two rectangles, and then there is a set A and there is a set B. So the complement of set A is this light brown area, and again similar to that, the complement of set B is this light brown area, and then the second image. So now to do an intersection, what I'll do is I'll just take this particular image and put it on top of it. So if you notice here, this whole brown area, the light brown area, is the intersection area for A complement and B complement. And if you notice, this picture, this image is exactly same as my left hand side image, which of course was marked by the blue area in this. So this proves that left hand side is equal to the right hand side in the Venn diagram approach. In the next approach, let's take the theoretical proof also for this. So for this, what we will do is we'll assume a particular element. So that element, let's say, is X. So what we will say is, let's say X belongs to A union B complement. So this is just an assumption that X belongs to A union B complement. Now if it belongs to A union B complement, what that means is it does not belong to A union B, because by definition complement is just opposite of a normal set. So now if it does not belong to A union B, that tells me that X does not belong to A, and also X does not belong to B, because if it is not part of the union, it is not part of either of the sets. So now if you from this you can easily derive that if it does not belong to A, that means it belongs to A complement, and X belongs to B complement. And this AND operator is nothing but an intersection. So that implies that X belongs to A intersection, A complement intersection B complement. So which is nothing but our De Morgan's law. So we started with X belonging to A union B complement, and we came down to X belongs to intersection of A complement and B complement. And now if you just want to put an example to this, right? So I have two sets, 2, 4, 6 and set 1, 3, 5. So combination, the union of set A and set B will be nothing but 1, 2, 3, 4, 5 and 6. If you again apply it back to our equation, so let's say X belongs to A union B. Let's pick a number which is not here because it's A union B complement. Let's say 7. So we know 7 does not belong to A union B complement. So which tells me it belongs to A union B complement, which tells me that 7 does not belongs to A union B, which is true. 7 is not part of it, which tells me that 7 does not belong to either A, which is also true because it is not part of set A, and also it implies that it does not belong to set B, which is also true because 7 is not part of this. From that we derived that it belongs to A complement, which is true, and then we derived that it belongs to B complement, which is also true, which tells me that X belongs to A complement intersection B complements. Hence, we proved the De Morgan's law through an example, through a Venn diagram, and of course through an theoretical approach also. Thank you. And in the next session, we will cover the second part of De Morgan's law. Thank you.